Topics for this lesson: propagation of unicast frames across multiple switches. Up until now, we have seen how a standalone layer 2 switch handles the unicast frame. Now we will expand our coverage and see how a unicast frame propagates across multiple switches. Next, we will look at broadcast frames and in context with layer 2 switches. How does a layer 2 switch and multiple layer 2 switches handle broadcast frames? We will also do analysis of broadcast domains. In the previous chapters or lessons, we had covered hub and the broadcast domains. Now we will do a similar discussion on broadcast domains related to layer 2 switches. Next, we will go over the concept of unknown unicast. This is an industry term for unicast frames which are not in the MAC table, and that's why they are known as unknown unicast. We will go into details of these, and we'll define what exactly is the unknown unicast. And similarly, we will also define what is a known unicast. And finally, we'll go over the questions related to these topics and concepts that get asked in the interview. So let's expand our LAN. We had our switch S1. Let's add another switch S2 and connect them together. Here, the port P4 of switch 1 is connected to port P3 of switch 2. And then we have further connections like these for PC4, 5, and 6 with the corresponding MAC addresses D, E, and F. So the key point here is that each switch maintains its own MAC table and they make their own independent decisions. We will go over a frame, take a frame and make it transit from starting from the PC and see how it interacts with switches as it takes its path. Okay. So PC1, let's say, wants to send data to PC2, creates a frame, DA with B and SA is equal to A. Send it out of the NIC to the wire. It reaches the switch 1. We know that the switch 1 will make its decision. First step, check the source MAC address. Accordingly, make the entry is not there. It will create an entry. It has done that here. Next, it will check the DA field. And since the DA field has a value of B and the B MAC address is not found in the MAC table, the obvious result of this is the flooding of the frame on all the other ports. As a result, it gets flooded out of port P2, P3, P4 of switch S1. It goes there. A copy of the frame now reaches PC2, PC3, and port P3 of switch S2. Let us analyze these one at a time, starting from PC2, and then to PC3, and then how switch will read. So start with PC2. So PC2 has received the frame, check the DA, finds the DA is equal to B. It is a match, hence it accepts the frame. Okay. Next, PC3 checks the DA value of the DA, and then find it to be B, compares it with its own MAC address, which is C. It is not a match, and hence it discards the frame. Okay. Moving on to switch 2. The frame is received on port P3. So what does it do? Switch 2 doesn't care where the frame is coming from. It just checks the source address field. It finds it to be A. In its MAC table, it does not have an entry, so it makes an entry in the MAC table. Source address is equal to A, and port corresponding port be P3. So it makes an entry. Okay. Next, it checks the destination address, which is B. And again, entry for B is not in the MAC table, so it is have no other option but to flood the frame. Of course, these frames reach PC 4, 5, and 6, which also check the destination address field of the frame. It's B and it does not match either D, E, or F, hence all three of them, just discard the frame. So this is how a unicast frame gets propagated across multiple layer 2 switches. Concept is same. Step by step, take one switch at a time and make it walk through the steps. Step 1 and step 2 of both, and see if the MAC table is having an entry or not having an entry, populate it, or accordingly make a decision. Nothing changes. The key is analyze one switch at a time. How will it act? Okay. Now, moving on to broadcast. How do layer 2 switches handle broadcast? So in this case, PC1 wants to send data to all. It creates a frame, source address A and destination all, sends it out. PC1, switch 1 receives it on port P1. Again, the step 1 followed is same. By now, you guys should have got used to it. First step is check the source address field, find it to be A. It is not in the check it whether A is in the MAC table or not. It is not there. So create an entry for A in the MAC table at the corresponding port P1. That is what it should do, right? So here it does it. Next, check the destination address field. It is all, right? All is not in the MAC table and it will never be in the MAC table. Why it will not be in the MAC table is a question that I want to ask you guys to come up and think. I'll give you a hint though, but wait for it in a bit. So it finds it to be all. The all is not there in the MAC table, so it floods it across all the 3 ports. Okay. So now when it has flooded this, a copy of the frame reaches PC2, 3, and 4. All check the destination MAC address of the frame. Find it to be all. All is intended for everyone, and hence all of them accept it. L2 switch will always flood a broadcast frame. So remember, unicast or broadcast frame, who transmits it? It's the originating PC who makes the decision whether to send a unicast or a broadcast. Okay. Switch does not change a unicast to a broadcast. Switch just does the flooding or forwarding. So don't get confused between flooding and broadcasting. Okay. Switch will never broadcast a frame. Switch will always either flood a frame or forward a frame. Okay. So this is how a layer 2 switch handles the broadcast. Now let us see how, if we have 2 LANs, what exactly is the meaning of 2 LANs. Here we have 2 switches, S1 and S2, both are independent. They are not connected to each other. Basically, they are 2 different LANs and they both have their own MAC table. Right? So, and if in this case, let's say PC1 wants to send a broadcast, send a message to all. Likewise, in PC4 wants to send a broadcast. They both create their own frames. Source address in this case is A, source address in this case is E. They send it. And S1 receives this frame, S2 receives this frame. They do their own step 1. Check the MAC at the source address. This switch does not have source address with the value of A in the MAC table, so it will learn it. This switch does not have source address E in the MAC table, so it will learn it. This will learn on port 1 on A, and this will learn E on port 1. So the entries get populated like this. Next, they both check the destination address field. They don't find it, and hence they both flood it. So this is how they are 2 different LANs. There are 2 different LANs. This is LAN number 1, and it comprises itself into a broadcast domain. We can call it as a broadcast domain 1. And similarly, this is the second LAN, and it will be its own broadcast domain. So whatever broadcasts any of these PCs send will be limited or restricted to this domain. Hence, it is called its own broadcast domain. And similarly, if any of the PCs in this LAN send the broadcast, it will be restricted or distributed to members that are part of the switch. So it becomes another broadcast domain. So what happens now when we merge the two networks together? So we had these, we connected them together, S1, S2. Now these are connected. And now they have their own MAC tables, but if let's assume that PC1 sends the broadcast, what happens? So PC source switch 1 receives the frame, makes an entry, learns the MAC address A on port P1, does not have entry all in the MAC table, so it floods the frame. Frame goes to PC2 and PC3. They both will accept it because it's intended for everyone. So let's not go there. We all understand they will both accept it. Switch to receives it on port P3, checks the source address field. It is A. Again, it doesn't have the entry in the MAC table, so make the entry in the MAC table. All good. Next, looks at the destination address, doesn't find the value, so floods the frame out. And similarly, so all the PCs will receive it and all will accept it. So this is a single LAN and one broadcast domain. So if whatever single PC, whichever PC sends the broadcast, all other PCs or host or end devices will receive it and accept it. So hence, two PCs, two switches connected together form a single broadcast domain. Now, let me just elaborate a little bit further on this point. This is a key point. And once you have this concept, then it will help you visualize and be able to explain it. So each switch has its acts as an independent entity here. Now, in this case, think about it, right? This was the switch. Let's just say that switch 2 is doesn't have any awareness where the frame is coming to, right? It does not know what is on this side. When it is receiving a frame, it does not know where it is receiving from a PC or another switch, doesn't know. It just knows that it gets a frame, and then independently it's supposed to make a decision of checking the source MAC address and then populating the entry, and then step 2, either forwarding or flooding. In this case, the destination address is not in the MAC table, so it will flood it. So this is what is independent making decisions of the switch. Next, let's look at what is the known unicast. So whenever a switch receives a unicast frame, we know a unicast frame is the one which has destination address field, that is the unicast address. So when a frame receives a unicast frame, and the entry of that for the destination address is in the MAC table, then it is known as a unicast frame, known unicast. Okay, so let's take this example. So at present, the MAC table has an entry already by some process of learning. I'm assuming that MAC address E is on port P1. Now, switch 2 receives the frame with the source address A and destination address E. The first step, check the source address. If it is in the MAC table, if it is not in the MAC table, make an entry. So it makes an entry. Next, check the destination address. It has the value E, and E is in the MAC table. So the switch knows where exactly is MAC address E. Hence, this is known as a known unicast. I'll just read the definition. If a switch receives a unicast frame with the destination field having a MAC that does have an entry in the MAC table, then the switch is aware of where to send it. Such a frame is known as known unicast, and the frames get forwarded. So this is what gets done. Moving on, unknown unicast. So the difference here is that the MAC table is entry, and when it receives the frame, let's say here, so in this case, it does not know where to send the frame. The source address is not there, so it will make an entry. A is on the port learn on port P3, check the destination address B. It's not knowing where exactly B resides, so it is supposed to flood it. And hence, it does not know. So again, unknown unicast is a unicast frame to the switch. It does not know where to forward it, and hence it floods it. And such type of frames are known as unknown unicast. You can go over the definition here. The switch receives a unicast frame with a destination and a field having a MAC that does not have an entry in the MAC table. Then switch is unaware of where to send it. Such a frame is known as unknown unicast, and it gets flooded. Okay. The key takeaways. Each switch maintains its own MAC table. Each switch makes its own independent decisions. Unknown unicast gets flooded, and known unicast gets forwarded. Further, switch will always flood a broadcast frame. A broadcast MAC address can never be in a MAC table. The reason it cannot be in the MAC table is because the MAC table gets populated looking at the source address field of a frame. And since a broadcast address can never be a source address, that is the reason it can never be in a MAC table. And that's the reason it will never be in the MAC table. And because it is not in the MAC table, it always gets flooded. Each L2 LAN is a broadcast domain by itself. And when we merge two L2 LANs, layer 2 LANs, they become a single LAN. The broadcast domain also converges into one. Interview questions. Should be able to explain how or walk through the steps when a frame is transmitted by a end device PC host. What steps take place when it encounters multiple switches on its path. You should be able to explain what exactly is the concept of known and unknown unicast. Be able to explain why the switch always flood broadcast frames, why broadcast MAC address can never be in MAC table. You should be able to explain that also. And finally explain the concept of broadcast domains in L2 switch environment. In next lesson, we will cover how layer 2 switches filter traffic. And by doing this filtering, how do they add efficiency by saving bandwidth and CPU cycles for the PCs. And we will also discuss the questions related to this topic that get asked in the interview.